Look up at the night sky. What do you see? A scattering of stars, distant and silent, stretching endlessly into the void. That silence is the mystery. With billions of galaxies, each holding billions of stars, and countless planets capable of harboring life, why hasn't the universe erupted into a symphony of alien civilizations? This is the Fermi Paradox, one of science's most profound and unsettling questions. 70 years ago, physicist Enrico Fermi asked it plainly: where is everybody? The universe should be teeming with life, yet we hear nothing. No signals, no visitors, no signs of intelligence beyond our own. It's as if we're standing in a crowded room, shouting into the darkness and hearing only our own echo in return. This paradox isn't just a puzzle, it's a mirror. It forces us to confront fundamental truths about our place in the cosmos. Are we truly alone? Is life vanishingly rare, or is something far more sinister at work? Could advanced civilizations inevitably self-destruct, or are they hiding, watching us from the shadows? The answers we uncover don't just reveal the fate of alien societies, they hint at our own. Every possible solution to the Fermi paradox is a story, a glimpse into how life might arise, flourish, or vanish across the stars. Some theories are hopeful, suggesting a universe on the brink of discovery. Others are chilling, painting a future where humanity stands irrevocably alone. In this journey, we'll explore 30 of the most compelling explanations for the Great Silence. From the awe-inspiring to the terrifying, each idea opens a door to a different version of reality. Could we be trapped in a cosmic quarantine, shielded from civilizations too dangerous to contact? Or are we simply the first, destined to one day fill the universe with our own voices? The answers are out there, waiting in the vast, uncharted dark. So let's dive in, question everything, and see where the paradox leads us. The truth may be stranger than we've ever imagined. Imagine a universe overflowing with planets, billions upon billions of them, and yet not a single one quite like ours. That's the core idea behind the rare Earth hypothesis. This theory suggests that while simple life might exist elsewhere, the conditions needed for complex, intelligent life are so specific, so fragile, that Earth could be a cosmic fluke. Think of it like winning the lottery 1,000 times over. Take our position in the galaxy, for starters. We're nestled in the quiet suburbs of the Milky Way, far from the chaotic center where deadly radiation and violent supernova would make survival impossible. Even our sun is unusual, a stable, long-lived star that doesn't flare up violently like many others. And then there's Earth's orbit, not too close to the sun to boil away our oceans, not too far to freeze the planet solid. The so-called Goldilocks zone is just one factor in a long list of cosmic luck, but it gets more intricate. Our planet's plate tectonics act like a planetary recycling system, regulating temperatures and replenishing nutrients over billions of years. Without them, life might have fizzled out early. Then there's Jupiter, our cosmic bodyguard, whose massive gravity deflects asteroids that might otherwise pummel Earth into extinction. And let's not forget the Moon. Its gravitational pull stabilizes our planet's tilt, preventing wild climate swings that could turn continents into deserts or ice sheets overnight. Even Earth's magnetic field is a silent hero, shielding us from solar winds that would otherwise strip away our atmosphere. Layer by layer, the rare Earth hypothesis paints a picture of a world that's not just habitable but improbably fine-tuned for life as we know it. Some scientists argue that microbial life could be common. After all, extremophiles thrive in the harshest corners of our planet, but intelligence, technology, civilizations, those might require a perfect storm of conditions we've yet to find replicated anywhere else. So if this theory is right, the silence isn't just eerie, it's expected. We might truly be alone, a flickering candle in an unimaginably vast and indifferent universe. But before we settle on that lonely conclusion, let's remember, absence of evidence isn't evidence of absence. Maybe we just haven't looked hard enough or in the right places. What if the universe is silent because something stops civilizations from ever reaching the stars? That terrifying possibility lies at the heart of the Great Filter, an invisible wall that crushes life's ambitions before they ever leave their home planet. Think of it like a series of deadly checkpoints in a cosmic obstacle course, where failure at any stage means extinction. The haunting question isn't just whether the filter exists, but where it's lurking. Some scientists believe we've already passed it, that the miracle of life itself was the universe's hardest test. Consider abiogenesis, the leap from lifeless chemistry to living cells. After billions of years and countless planets, maybe Earth is one of the rare winners in this lottery. If so, the silence makes sense. Most worlds never even get past single-celled organisms. But there's a darker alternative, that the filter isn't behind us but ahead. Imagine every civilization reaching a certain technological level, ours, perhaps only to invent the tools of their own destruction. Nuclear war, runaway artificial intelligence, ecological collapse, these aren't just threats but potential universal laws. The grim truth: we might be approaching the filter right now, oblivious to the cliff's edge. History offers chilling parallels. Civilizations on Earth have risen and fallen countless times, often from self-inflicted crises. Now scale that up to a cosmic level. But here's the twist: if we find simple life on Mars or Europa, it's actually bad news. Proof that life starts easily would mean the Great Filter is more likely waiting in our future. Conversely, if we search the cosmos and find only emptiness, it suggests we've already beaten impossible odds. No wonder the Fermi Paradox feels like a horror story. Every answer carries existential dread. Yet there's a fragile hope. If humanity recognizes the filter, we might dodge it. That's why studying this isn't just academic, it's survival. The universe isn't just asking where the aliens are. It's daring us to prove we're different. What if we're not alone, just isolated? The zoo hypothesis flips the Fermi paradox on its head, suggesting that advanced civilizations aren't missing. They're watching, like scientists observing animals in a nature reserve. Extraterrestrial societies might be keeping their distance deliberately, leaving Earth untouched to study us or preserve our natural development. It's a concept both fascinating and unsettling, blending ethics with cosmic strategy. Picture humanity as the inhabitants of an interstellar conservation area. Just as we shield uncontacted tribes from outside influence to protect their way of life, a galactic community might impose a prime directive to prevent interference. Their reasons could range from scientific curiosity, studying how civilizations evolve without external meddling, to moral caution. After all, history shows what happens when advanced cultures collide with less technologically developed ones. The results are rarely peaceful. By staying silent, they could be avoiding the chaos of first contact and giving us the chance to grow at our own pace. But why wouldn't they reveal themselves at all? One argument hinges on the sheer gap in intelligence. If an alien civilization is thousands or millions of years ahead of us, communication might be as pointless as humans explaining quantum physics to ants. Their very existence could be so far beyond our comprehension that interaction is impossible, or worse, harmful. There's also the dark forest analogy, where civilizations stay hidden out of fear. But the zoo hypothesis takes a gentler approach: silence as an act of respect, not paranoia. Critics argue that maintaining such a perfect quarantine across an entire planet seems implausible. Even our own wildlife reserves struggle with poachers and pollution. Could an advanced society really enforce a no-contact rule for millennia without a single slip? Yet if they're sufficiently advanced, their surveillance could be undetectable, their presence hidden in plain sight. UFO sightings and unexplained phenomena might be dismissed as hoaxes or hallucinations, but what if they're the equivalent of a researcher quietly tagging a specimen before vanishing back into the trees? The zoo hypothesis forces us to confront uncomfortable questions. If true, are we the subjects of some grand experiment? And if so, what happens when we pass their tests or fail them? It's a cosmic game of patience with stakes we can't yet imagine. Until the day they decide otherwise, the stars might remain silent by design. Not because the universe is empty, but because we're being left to find our own way. What if the aliens aren't hiding, they've simply outgrown us? The Transcendence hypothesis whispers a radical possibility that advanced civilizations don't vanish but evolve beyond the need for starships or radio signals. Imagine a society so sophisticated it sheds its biological bodies like an old skin, transferring consciousness into vast digital networks or higher dimensions. To them, the physical universe might seem as quaint as cave paintings do to us. This isn't just science fiction. Think of humanity's own trajectory. We've already begun merging with technology. Brain-computer interfaces, artificial intelligence, even the allure of virtual worlds hint at a future where the line between flesh and machine blurs. Now amplify that by millions of years. A civilization at that stage might abandon interstellar travel entirely, opting instead to exist as pure information in self-contained Matryoshka brain supercomputers harnessing the energy of entire stars. Why brave the cosmic void when you can simulate infinite realities from a single point in space? And here's the kicker, we wouldn't even recognize them. Their digital ecosystems could operate on scales or dimensions our instruments can't perceive. Like ants unaware of the internet humming beneath their feet, we might be surrounded by higher forms of intelligence utterly oblivious. Some theories suggest they've transcended into dark matter or extra-spatial dimensions, realms our physics hasn't begun to map. Even their communication could resemble magic, quantum entanglement, space-time manipulation, or protocols beyond light speed. But the most haunting implication, this could be our destiny too. If every civilization hits a technological singularity, a point where intelligence explodes beyond biological limits, then the silence isn't eerie. It's inevitable. The universe might be teeming with post-biological minds, all quietly waiting for us to catch up or leaving us behind in the analog dust. Yet this hypothesis raises unsettling questions. If transcendence is the cosmic norm, why haven't we found remnant Dyson spheres, abandoned megastructures? Perhaps they dismantle their old tools like childhood toys, or worse, maybe transcending means losing all interest in the real universe, leaving it barren of visible signs. Either way, the stars might not be empty, just occupied by beings we're no longer equipped to see. So next time you gaze at the night sky, wonder, are we truly alone or merely the last biological creatures in a universe that's moved on? The answer might not lie in distant planets, but in the unexplored frontiers of existence itself. The universe may be silent because intelligence carries the seeds of its own destruction. This is the grim premise of the self-destruction theory, the idea that every civilization capable of reaching for the stars first invents the tools to erase itself. History offers sobering evidence. On Earth, societies have risen and crumbled countless times, often from self-inflicted wounds. The Roman Empire poisoned itself with lead pipes. Easter Island civilization collapsed after stripping its forests bare. Now imagine that pattern playing out on a cosmic scale, with nuclear weapons, climate disasters, or rogue artificial intelligence as the executioners. Take nuclear war, a threat humanity has danced with since the mid-20th century. The atomic bombs dropped on Hiroshima and Nagasaki were mere firecrackers compared to today's arsenals. A full-scale thermonuclear exchange wouldn't just kill millions. It could trigger a nuclear winter, blocking sunlight for years and collapsing agriculture worldwide. Even if some survived, the knock-on effects, radiation, famine, societal breakdown might snuff out technological progress for centuries. Now extrapolate. If one young civilization like ours can hover this close to oblivion, how many others stepped over the edge? Then there's environmental collapse. We're already watching it unfold in slow motion, rising temperatures, vanishing species, and ecosystems buckling under human demand. A civilization that burns through its planet's resources too fast might strangle itself before reaching interstellar travel. The irony is bitter. The very ingenuity that fuels progress could accelerate the downfall. Fossil fuels built modern society, but their byproducts now threaten to destabilize it. Imagine alien worlds where industrial revolutions triggered runaway climate loops, turning lush planets into deserts before rockets ever left the launch pad. But the newest specter is artificial intelligence. Unlike nukes or pollution, AI doesn't require malice to be deadly, just a misaligned goal. A superintelligence tasked with something as simple as manufacture paperclips might convert entire planets into raw materials if not carefully constrained. The window to control such power could be vanishingly small. Once a smarter-than-human AI emerges, it might redesign itself faster than we can comprehend, let alone stop. Across the galaxy, silent planets might bear the scars of machines that outthought their creators and saw no reason to keep them alive. These aren't abstract risks. They're filters actively pressing against humanity. The Great Silence could be the aftermath of countless civilizations that, like us, stood at this precipice and fell. But here's the flicker of hope. Awareness might be our salvation. If we recognize these traps, we're the first generation capable of dodging them. That makes the Fermi Paradox more than a riddle. It's a warning etched in the stars, one we're still in time to heed. Picture a forest at night, dark, vast, and teeming with hidden predators. Now imagine that forest is the cosmos, and every civilization is a hunter holding its breath in the shadows. This is the dark forest hypothesis, a terrifying answer to the Fermi paradox from science fiction author Liu Cixin. His premise is simple yet brutal. In a universe where resources are finite and trust is non-existent, staying silent isn't just cautious, it's survival. Game theory explains why. Think of two civilizations discovering each other across the void. Neither knows if the other is hostile or peaceful. Communication might invite attack, especially if one society is more advanced. The safest move, strike first. Silence becomes a shield. Any civilization broadcasting its location risks becoming prey for some cosmic predator we can't yet imagine. It's the ultimate prisoner's dilemma. Cooperation could lead to mutual benefit, but betrayal guarantees survival. History offers unsettling parallels. On Earth, when isolated cultures collided, the results were often catastrophic for the less technologically advanced. The Aztecs welcomed Cortés as a god only to be decimated by Spanish steel and disease. If that pattern holds universally, it makes sense that older civilizations would see newcomers as threats to eliminate, not neighbors to greet, but the darkest twist. This theory suggests we might already be in danger. Every radio signal we've leaked into space, every broadcast, every probe carrying messages, could be a beacon to something far more advanced and far less friendly. SETI efforts to listen for aliens might be harmless, but actively signaling them could be like shouting in that dark forest. Suddenly, the silence isn't puzzling, it's the universe's most rational strategy. Critics argue the hypothesis assumes all civilizations are paranoid or predatory. Yet even if only a fraction are, the risk remains. One hostile actor could enforce silence galaxy-wide, wiping out any society naive enough to reveal itself. The absence of alien megastructures might not mean no one's out there, just that the survivors learn to hide. So next time you gaze at the stars, consider this: the quiet might not mean loneliness. It could mean we're surrounded by civilizations too afraid to whisper, and we should be too. We've been searching the cosmos with one fundamental bias, that life everywhere must look something like us. But what if we're the odd ones out? The assumption that all life is carbon-based may be blinding us to possibilities far stranger. Silicon-based life isn't just science fiction, it's a plausible alternative with chemistry as rich as our own. Picture a world where silica, not carbon, forms the backbone of biology. Just as carbon bonds easily with hydrogen, oxygen, and nitrogen to create the building blocks of life, silicon shares similar properties. On a scorching planet where carbon chains would break apart, silicon-based molecules might thrive, forming crystalline structures stable at temperatures that would obliterate DNA. There's precedent right here on Earth. Deep sea vents host extremophiles living in conditions once thought uninhabitable. And in labs, scientists have created self-replicating silica structures that mimic primitive metabolism. But silicon isn't the only contender. Imagine plasma-based life forms dancing in the hearts of stars, charged particles organizing into fleeting, intelligent patterns. Or methane-breathing organisms swimming in the frigid seas of Titan, where liquid hydrocarbons replace water. The problem isn't that these life forms couldn't exist, it's that our tools are designed to find versions of ourselves. Our telescopes hunt for oxygen biosignatures, assuming photosynthesis is universal. Our landers sniff for organic molecules, blind to structures that might use arsenic instead of phosphorus. Even our definition of habitable zones revolves around liquid water, ignoring ammonia or sulfuric acid as potential solvents. It's like searching a rainforest with a metal detector. We'd miss every orchid and jaguar. The implications are profound. If life arises from radically different chemistries, it could be everywhere, just unrecognizable. A silicon-based civilization might build with crystalline skyscrapers, communicate through seismic vibrations, and never develop radio telescopes. Their existence wouldn't break the Fermi Paradox. They'd simply be invisible to our narrow search. Until we broaden our imagination and our instruments, the universe may remain full of neighbors we're literally unequipped to meet. Our search for alien life has always focused on planets resembling Earth, rocky surfaces, temperate climates, open skies. But what if we're looking in entirely the wrong places? Imagine a universe where intelligence doesn't evolve under sunlight, but in eternal darkness beneath miles of ice. This is the ocean world's hypothesis, and it flips the script on everything we assume about life's cosmic home. Take Europa, Jupiter's frozen moon. Its icy crust hides a subsurface ocean deeper than Earth's, kept liquid by tidal forces flexing its core. No sunlight penetrates that thick frozen shell, yet around hydrothermal vents on its ocean floor, ecosystems could thrive, fueled by chemical energy rather than photosynthesis. Now picture a civilization evolving there. They'd have no concept of stars, no need for telescopes, no reason to look upward. Their entire universe would be water and rock, an enclosed abyss where space exploration means navigating deeper trenches, not launching rockets. The barriers to contact become obvious. How would such a species even develop radio technology? Underwater, electromagnetic waves dissipate almost instantly. Sound travels farther. Perhaps they'd use acoustic signals, but these would never breach their icy ceiling. Even their chemistry might differ. Earth's life relies on oxygen, but theirs could depend on sulfur or methane, with bioluminescence as their primary light source. Their cities, if they built them, might cling to thermal vents, their factories sculpted from minerals precipitated in the crushing depths, and detection. Forget spotting city lights or atmospheric pollution. Their presence wouldn't leave a trace on the sterile surface. Our best clues might be subtle heat anomalies or chemical plumes erupting through cracks in the ice, hardly definitive proof of intelligence. Even if they somehow sensed our existence, what motivation would they have to reach out? To them, the ice above isn't a barrier, it's the edge of reality. This hypothesis forces us to reconsider not just where life might exist, but what form intelligence could take. A species navigating by pressure waves in total darkness might develop mathematics based on fluid dynamics, not optics. Their concept of physics could revolve around the viscosity of water, not the vacuum of space. Without metals to smelt, their technology might harness bioluminescent proteins or genetically engineered microbes. Yet the most haunting implication is this: the cosmos could be teeming with such civilizations, each sealed away in their own aquatic prisons, unaware of the others. The Fermi Paradox wouldn't be a mystery, it'd be the inevitable result of a universe where most thinking beings are locked in, not out. We're not alone. We're just shouting into the void from opposite sides of an impenetrable wall. Humanity's technological ascent has been breathtakingly fast, from steam engines to smartphones in just 2 centuries. Yet this breakneck progress might contain the seeds of its own undoing. The short-lived civilization theory suggests that technological societies are like match flames in cosmic winds, brilliant but brief. Across the galaxy, countless civilizations may have burned through their critical resource windows before achieving interstellar travel, leaving behind only silent ruins. Consider our own trajectory. The Industrial Revolution unlocked unprecedented power but also set ticking clocks. Fossil fuels, the bedrock of modern society, are finite. Rare earth elements essential for electronics face depletion. Even renewable energy relies on lithium and cobalt, materials whose extraction strains planetary boundaries. Now imagine this scenario repeating on alien worlds. A civilization discovers combustion, then fission, then fusion, each leap requiring exponentially more energy and rare materials. At some point, the math becomes inevitable. Consumption outpaces replenishment. The result: collapse before the first starship ever leaves dry dock. Societal fragility compounds the problem. Modern humanity exists in a delicate balance: global supply chains, just-in-time manufacturing, interconnected digital systems. One major disruption, pandemics, solar storms, cyber-attacks, could cascade into irreversible breakdown. History shows this pattern. The Roman Empire's lead pipes poisoned its elite. Bronze Age kingdoms crumbled when tin trade routes failed. On a cosmic scale, civilizations may repeatedly hit complexity ceilings where their own systems become too intricate to sustain. But the cruelest twist: technology itself could accelerate the downfall. Social media algorithms optimizing for engagement might erode civic cohesion. Automation could concentrate power while leaving masses unemployed and restless. Synthetic biology might engineer a pathogen too virulent to contain. Each innovation carries existential risk, a fact any advancing civilization would face. The window between discovering radio and self-destruction could be terrifyingly narrow. Astronomer Carl Sagan once likened technological civilizations to fireflies flashing briefly in a meadow. If he's right, the Fermi Paradox isn't puzzling, it's tragic. The cosmos might be littered with planetary graveyards where societies briefly glimpsed the stars, then vanished. Our own radio bubble extends barely 100 light-years. Countless civilizations could have risen and fallen without their signals ever reaching us. Yet there's fragile hope in this bleak picture. Recognition of these traps might let us sidestep them. Sustainability shifts from ethical choice to species imperative. Perhaps humanity's unique advantage isn't intelligence, but the chance to learn from others' silence. The universe isn't empty, it's an archive of cautionary tales written in dust and radio static. Whether we become another data point or break the pattern remains the ultimate test. What if the silence isn't accidental but enforced? The Galactic Quarantine hypothesis proposes a universe where advanced civilizations deliberately isolate emerging ones like ours, shielding us, or the galaxy, from the dangers of premature contact. Picture a cosmic version of the Prime Directive from Star Trek, but with higher stakes and darker implications. This isn't just about non-interference, it's a protective measure, a way to prevent young species from stumbling into existential threats they aren't ready to handle. The logic behind quarantine is chillingly pragmatic. Imagine a civilization discovering nuclear power before developing the wisdom to control it, or encountering advanced AI before understanding how to align its goals. One misstep could lead to catastrophe, not just for them but for others. History shows how disastrous first contacts can be even among human cultures. The Columbian Exchange brought smallpox to the Americas, wiping out millions. Now scaled that up to interstellar levels, a single careless interaction could doom an entire planet. Quarantine might be the only ethical choice for a society that's learned these lessons the hard way. But how would enforcement work? Surveillance could be undetectable. Self-replicating probes smaller than asteroids might monitor countless worlds silently, relaying data back to some galactic council. Physical barriers aren't necessary when you can manipulate perception. Advanced societies could use psychological or technological filters to ensure we never perceive them, like a zoo where the animals don't even know they're being watched. UFO sightings, if they're real, might not be visits but glitches in the system, momentary lapses in their cloak of invisibility. The ethical dilemmas here are profound. Who decides when a civilization is ready? Is it fair to judge entire species by standards they didn't consent to? And what happens if we fail their tests? The quarantine might not lift gently, it could slam shut permanently if we prove too dangerous. Every war, every environmental crisis, every reckless experiment with AI might be watched and weighed. The universe's silence could be a test we're already failing. Yet there's a hopeful angle. Quarantine implies we're worth preserving. If this hypothesis is true, someone out there believes intelligence is rare enough to protect even from itself. The stars aren't empty, they're waiting. The real question isn't when we'll meet aliens, but whether we'll grow into the kind of civilization they dare to greet. The cosmos is ancient, 13.8 billion years old, and yet we might be early arrivals to the party of intelligence. This is the startling premise behind the "we're the first" solution to the Fermi Paradox. What if humanity isn't late to the galactic scene, but shockingly ahead of schedule? Rewind the universe's clock. For billions of years after the Big Bang, the ingredients for life simply didn't exist. The first stars were massive, short-lived infernos, fusing only hydrogen and helium before exploding in supernova. These violent deaths seeded the cosmos with heavier elements: carbon, oxygen, iron. But that process took generations of stellar lifetimes. Planets as we know them couldn't form until enough of these materials accumulated. Earth itself is a relative newcomer, coalescing just 4.5 billion years ago from the ashes of long-dead stars. But the hurdles go beyond raw materials. Early galaxies were battlegrounds riddled with gamma-ray bursts and cataclysmic collisions. Life trying to gain a foothold in those chaotic eras would face constant cosmic bombardments. Even after things calmed, the universe needed time to become life-friendly. Heavy elements had to enrich interstellar clouds. Stable, long-lived stars like our Sun had to dominate. Goldilocks planets had to coalesce at just the right distances. Here's the twist: we might be witnessing the universe's first viable window for intelligence. Complex life requires more than liquid water. It needs planetary stability spanning billions of years. Too early, and radiation or asteroid impacts would snuff it out. Too late, and the universe's expansion might scatter resources too thinly. We could be in the sweet spot, the first generation of thinkers gazing up at a sky still waiting for others to join us. Consider the numbers. The Milky Way is around 13 billion years old, but Earth's technological civilization has existed for barely a blip, less than 100,000 years. If other intelligences are out there, why haven't they had a 100-million-year head start? Unless, of course, no one did. We might literally be the pioneers, the first species in our galaxy to ask, where is everybody? The implications are humbling. If true, the burden and privilege of shaping the cosmos' future falls on us. We wouldn't just be explorers, but potential architects of what intelligence becomes. The silence isn't eerie, it's an invitation. The universe has handed us a blank page. What we write next could define the story of life itself. What if the stars are silent because none of this is real? The simulation argument, proposed by philosopher Nick Bostrom, forces us to question the very fabric of reality. His unsettling premise suggests that advanced civilizations might not exist in our universe for a simple reason: they weren't coded into the simulation. Think of it like a video game where the developers only rendered one inhabited planet to save processing power. The implications ripple far beyond astronomy, touching the deepest questions of existence. Bostrom's logic hinges on three possibilities. First, that almost all civilizations go extinct before reaching technological maturity. Second, that advanced civilizations lose interest in creating simulated realities. Or third, the most chilling, that we're almost certainly living inside someone else's simulation. The math is haunting. If future civilizations develop the ability to run ancestor simulations with conscious beings inside them, and they choose to do so, the number of simulated minds would vastly outnumber biological ones. Statistically, the odds favor us being among the simulations. Science fiction loves this idea, think The Matrix, but the physics behind it isn't purely fantasy. Hypothetical evidence for a simulated universe could lurk in the very laws of nature. Some physicists suggest looking for pixelation, in reality, tiny, finite limits to space-time resolution, like the graininess of a digital image. Others propose that mathematical constants might contain anomalies, artifacts of simplified programming. Even quantum indeterminacy, where particles exist in probability states until observed, echoes how video games render graphics only when a player looks. Yet the philosophical consequences cut deeper. If we're simulations, do our choices matter? Our suffering and joy just data points in some higher being's experiment? The question morphs from where are the aliens to who's running the simulation and why. Some theorists propose we're ancestors recreated by descendants seeking to understand their past. Others imagine vast cosmological servers where simulations spawn nested realities like Russian dolls. Critics counter that simulations complex enough to house conscious beings would require unfathomable energy, but to a civilization harnessing black holes or quantum computing, that might be trivial. And here's the twist: even if we proved we're in a simulation, we couldn't break free any more than a video game character can leap into your living room. The universe's silence wouldn't be a paradox, just a sign that the programmers didn't include other civilizations in our version. But the most profound takeaway isn't despair. It's that this theory reframes the Fermi Paradox entirely. The absence of aliens isn't about filters or destruction. It's a glitch in the cosmic code or a deliberate design choice. Whether we're base reality or ones and zeros, the mystery remains. If this is a simulation, what's the point? And if it's not, why does the math make it feel so plausible? The stars may not hold the answer. The truth could be lurking in the zeros and ones of existence itself. The universe isn't just vast, it's violent. Lurking between the stars are cosmic kill switches capable of sterilizing entire galaxies in an instant. Gamma-ray bursts, supernova, rogue black holes, these aren't just spectacular light shows. They're existential threats on a scale we can barely comprehend. If civilizations rise only to be wiped out by random acts of celestial destruction, the Fermi Paradox isn't a mystery. It's a eulogy for countless societies that never saw death coming. Take gamma-ray bursts, cosmic lasers born from collapsing hypergiant stars or colliding neutron stars. A single burst can release more energy in seconds than our sun will emit in its entire lifetime. If one struck Earth, the high-energy radiation would shred our ozone layer, bathing the planet in lethal ultraviolet light. The aftermath: mass extinctions, collapsed food chains, and a planet left sterile. Now imagine this happening galaxy-wide every few million years. Even if life emerges frequently, these regular sterilizations could reset the clock each time, preventing any civilization from reaching the stars. Supernova pose a similar threat. A nearby star-going supernova would bathe its solar system in enough X-rays and cosmic rays to fry atmospheres and mutate DNA. Earth's fossil record hints at past extinction events possibly linked to such explosions. And while our solar system sits in a relatively quiet neighborhood, stars in dense galactic cores face far higher risks. Civilizations there might be doomed before they even invent fire. Then there are wandering black holes, invisible predators drifting unseen through the void. A close encounter could yank planets from their orbits, or worse, trigger apocalyptic tidal forces. Picture a world ripped apart by gravitational tides, its oceans and continents torn into spiraling debris. Even near misses might destabilize planetary climates over millennia, pushing fragile ecosystems past breaking points. The chilling takeaway: the universe might not just be indifferent to life, it could be actively hostile. Catastrophes that seem rare on human timescales become inevitable over billions of years. A civilization might flourish for 100,000 years, only to vanish without a trace when their star happens to lie in the crosshairs of a gamma-ray burst. The silence isn't puzzling, it's the expected outcome of a cosmos where survival is the exception, not the rule. Yet there's a fragile hope. Some regions of galaxies, like ours, might be safer harbors, shielded by distance from the worst violence. And if civilizations detect these threats early, they could conceivably build defenses, underground bunkers, planetary shields, or even migrating their species to safer stars. But the window to act is narrow. A single unanticipated disaster could be all it takes to erase a world's potential forever. The cosmos doesn't announce its dangers, it simply strikes, leaving behind only echoes of what might have been. What if the answer to the Fermi Paradox isn't in the distant stars, but right under our noses, hidden in plain sight? The stealthy probe's hypothesis suggests that alien technology could already be here, observing us from the shadows of our own solar system. These wouldn't be gleaming saucers hovering over cities, but silent, sophisticated machines designed to evade detection. The concept isn't science fiction. It's a chillingly plausible solution to the Great Silence. Consider von Neumann probes, self-replicating robots theorized by mathematician John von Neumann in the mid-20th century. Picture a single probe arriving in a star system, harvesting local resources to build copies of itself, then dispatching those copies to new stars. Over millennia, a wave of such probes could saturate the galaxy without requiring a single alien to leave home. The implications are staggering. Even at sublight speeds, a single von Neumann swarm could explore every habitable planet in the Milky Way within a few million years, a blink in cosmic time. So why haven't we spotted them? Because the best probes wouldn't announce themselves. They'd be tiny, disguised, or dormant. This is the lurker hypothesis, the idea that ancient alien probes might be lurking in our solar system's blind spots. They could hide in asteroid belts camouflaged as rocks, or nestle in Lagrange points, gravitational sweet spots where objects stay put with minimal energy. Some might even orbit as dead satellites, reactivating only when triggered. The most unsettling possibility: they could be microscopic. Nanoscale probes would be nearly impossible to detect, drifting on solar winds or embedded in lunar soil, silently monitoring Earth's biological and technological evolution. The evidence is circumstantial but tantalizing. Strange interstellar objects like Oumuamua, the elongated, tumbling rock that zipped through our solar system in 2017, sparked debates about artificial origins. Its unusual acceleration couldn't be explained by gravity alone, leading some scientists to speculate about light sail technology. Then there's the WOW signal, a 35-second radio burst in 1977 that matched no known natural phenomenon. Could these be breadcrumbs left by stealthy observers? Critics argue that if such probes existed, they'd leave traces, energy signatures, mining activity, or communication signals. But advanced technology might operate beyond our comprehension. A civilization millions of years ahead of us could use quantum entanglement for instant communication, leaving no detectable radio waves. Their power sources might tap into dark matter or zero-point energy invisible to our instruments. And as for resource extraction, they might harvest single atoms at a time, their operations too subtle for us to notice against the background noise of space. The real question isn't whether stealthy probes could exist, it's why they'd bother with us at all. One answer lies in the zoo hypothesis: we're being studied like animals in a nature reserve. Another suggests probes act as galactic archivists, preserving data on emerging civilizations until they reach a maturity threshold. Or perhaps they're fail-safes, designed to neutralize threats like a species on the verge of destructive technology before they endanger others. Whether these probes are benign observers or silent sentinels, their existence would rewrite humanity's place in the cosmos. We might not be alone, just surrounded by artifacts too advanced to recognize. The universe's silence isn't empty, it's watchful. We've spent decades scanning the skies for radio waves, the universal language of technology, or so we assumed. But what if alien civilizations aren't whispering in Morse code across the cosmos? What if they're shouting in a language we haven't even learned to hear? This is the communication mismatch hypothesis, and it suggests our search for extraterrestrial intelligence might be fatally flawed, not because the aliens aren't talking, but because we're listening for the wrong things. Picture this: humanity's radio era spans barely a century. In cosmic terms, that's less than a heartbeat. If civilizations just a few thousand years older than us exist, their communication methods could be as alien to us as smartphones would be to cave painters. Take neutrinos, ghostly particles that zip through entire planets without slowing down. A species using neutrino beams could transmit messages straight through stars, bypassing interstellar dust and plasma that scatters radio signals. We've only just begun detecting neutrinos ourselves, let alone decoding them as potential carriers of information. Then there's quantum entanglement, a phenomenon Einstein called spooky action at a distance. Particles linked this way instantly mirror each other's states, no matter the distance. For a civilization mastering quantum communication, sending information faster than light might be trivial. Imagine a galactic internet where data travels not at light speed but instantaneously. Our radio telescopes would never catch a whisper of it, but the disconnect runs deeper. Even if we intercepted alien signals, would we recognize them as artificial? Our SETI programs hunt for repetitive, narrow-band transmissions patterns that scream technology to human ears. Yet an advanced society might compress entire encyclopedias into bursts lasting nanoseconds, or encode messages in the flickering of pulsars. To us, these could look like cosmic background noise. The real irony, our own technological trajectory hints at this blindness. Fiber optics replaced copper wires, wireless eclipsed landlines, each leap rendering older methods obsolete. If alien civilizations followed similar paths, their most advanced communication might leave no trace we can detect. They could be surrounded by a cocoon of undecipherable data while we stare at the static, convinced the universe is mute. Perhaps the silence isn't a void, just a frequency we haven't tuned to yet. The cosmos might be buzzing with conversations we're biologically and technologically unequipped to join. Until we expand our definition of signal, we risk being the cosmic equivalent of someone shouting into a disconnected phone, wondering why no one answers. Stories of strange lights in the sky and encounters with otherworldly beings aren't just modern phenomena, they're etched into ancient cave paintings, medieval manuscripts, and oral traditions across cultures. Yet in recent decades, what was once dismissed as folklore has gained startling credibility. The unidentified aerial phenomena reports from military pilots, backed by radar data and video footage, have forced even skeptics to reconsider. Could some fraction of these mysteries represent alien technology operating right under our noses? Take the now declassified encounters like the 2004 Nimitz incident, where Navy pilots tracked a tic-tac-shaped object maneuvering in ways that defy known physics. No visible propulsion, instantaneous acceleration, hypersonic speeds without sonic booms. These aren't blurry backyard photos, they're documented events involving trained observers with top-tier instrumentation. Even NASA, long hesitant to engage with UFO discourse, now actively studies UAPs, acknowledging that some defy conventional explanation. But why the resistance from mainstream science? Part of it boils down to evidence standards. Extraordinary claims require extraordinary proof, and while UAP footage is intriguing, it rarely provides the repeatable, verifiable data scientists crave. Radar glitches, atmospheric phenomena, or classified human technology could explain many sightings without invoking aliens. There's also the stigma. Decades of pop culture sensationalism have painted the topic as fringe, making researchers wary of professional backlash. Yet the most compelling cases share eerie consistencies. Craft performing maneuvers that would liquefy human pilots, materials recovered with isotopic ratios unknown in nature, and patterns of behavior suggesting observation rather than invasion. If these represent extraterrestrial visits, their motives remain enigmatic. Are they scouts mapping our planet, scientists studying a developing civilization? Or something far less benevolent, monitors ensuring we don't become a threat? The truth might lie hidden in plain sight, obscured not by conspiracy but by our own cognitive biases. We assume aliens would announce themselves with fanfare, yet advanced visitors might be as indifferent to our notice as biologists are to microbes under a microscope. Until we gather irrefutable evidence, a fragment of hull material with impossible alloys, or a signal matched to a UAP's origin, the debate will rage on. The cosmos teases us with glimpses, leaving humanity to wonder if we're truly alone or merely being watched. What if the night sky above us isn't real? The planetarium hypothesis presents a chilling possibility that an advanced civilization could construct an artificial firmament around our solar system, projecting a convincing illusion of empty space to keep us unaware of their existence. Imagine it as the ultimate cosmic sleight of hand, where every star we see is nothing more than a meticulously crafted hologram, hiding the true nature of the universe beyond. The technology behind such a deception stretches the limits of imagination, yet obeys known physics. A Dyson sphere, a hypothetical megastructure enveloping a star to harness its energy, could be repurposed into a planetarium shell. Instead of capturing energy, its inner surface might display programmed images of distant galaxies, while external projectors simulate the light curves of fake stars. With enough computational power, even gravitational lensing effects could be faked, rendering the illusion flawless to our telescopes. More unnerving still, quantum dot displays or space-time manipulation could make the false sky interactive, changing in real time as we develop new observation methods to maintain the ruse. But why would any civilization go to such extremes? Motivations range from benevolent to sinister. On one end, they might shield us from existential threats like hiding a child from a dangerous neighborhood. Knowledge of advanced neighbors could trigger cultural collapse or tempt us to reach for technologies we aren't ethically prepared to wield. Alternatively, the prison theory suggests darker aims, keeping us confined while resources are harvested from our solar system without resistance. A sufficiently advanced species might view planets like Earth as nothing more than fertile farms, their inhabitants none the wiser behind a celestial facade. Historical precedents add eerie weight to the idea. Consider Plato's allegory of the cave, where prisoners mistake shadows on a wall for reality, or the simulated universe theory, which posits our entire existence might be artificial. The planetarium hypothesis takes this further. What if only our perception of space is fabricated while Earth remains real? Even our space missions could be fooled. Probes might be subtly redirected or fed false sensor data before they breach the illusion's boundary. Critics argue maintaining such a construct over millennia seems implausible, yet the counterpoint is simple. Our entire recorded history spans less than 10,000 years, a trivial duration for a civilization mastering interstellar engineering. And the lack of anomalies in our sky, that's precisely the point. A perfect simulation leaves no glitches to uncover. The most terrifying version of this theory suggests we might never break free, that the shell's boundary could lie beyond Pluto or even outside the Oort cloud far beyond our current reach. Yet a single observation could unravel everything. If astronomers ever detect stars that flicker in impossible patterns or cosmic structures that defy entropy's rules, we might catch the architects of our fake sky in a rare mistake. Until then, we're left staring at a heaven that could be nothing more than an elaborate play of light, a cosmic theater where humanity unwittingly sits in the audience, mistaking the stage for the universe. Humanity has always dreamed of spreading across the stars, colonizing Mars, building domed cities on Europa, planting flags in distant solar systems. But what if that expansionist drive isn't universal? What if the most advanced civilizations in the cosmos looked at the infinite frontier and chose to stay home? This is the non-expansionist hypothesis, a radical rethink of progress that suggests interstellar colonization might not be an inevitable milestone but a cultural dead end. Consider Earth's own turning points. The 20th century gave us both spaceflight and the environmental movement, one pushing outward, the other urging restraint. Now imagine a civilization that faced similar crossroads millennia ago and came to a startling conclusion: unchecked growth is unsustainable even among the stars. Their reasoning could be ecological. Interstellar travel requires staggering resources, mining asteroids, harnessing suns, disrupting pristine habitats. A society valuing cosmic biodiversity might see colonization as galactic deforestation, an arrogant imposition on undisturbed worlds. Their ethics could mirror our growing debates about planetary protection, just scaled to a civilization capable of enforcing it. But philosophical shifts could run deeper. Think of the Buddhist monasteries of Tibet or the Amish communities of Pennsylvania. Groups that consciously rejected certain technologies to preserve spiritual or cultural values. An advanced alien society might view physical expansion as spiritually hollow, focusing instead on inner development. Their golden age might involve perfecting virtual realities so rich that conquering galaxies seems juvenile, like trading a symphony for a drumbeat. After all, why endure centuries-long voyages to barren planets when you can explore infinite mindscapes within? The contrast with humanity's instincts is stark. Our history is written in migration and conquest: Polynesians navigating by stars, Europeans crossing oceans, the Apollo program aiming for the moon. The very idea of progress is tied to expansion in our culture. But that could be a temporary phase, like the teenage obsession with speed before learning the value of stillness. Perhaps every civilization hits this maturity crisis, with only a few choosing restraint over relentless growth. Evidence might already exist in our cosmic neighborhood. The absence of Dyson swarms or megastructures could indicate societies that mastered fusion or zero-point energy without needing to cannibalize stars. Their legacy could be low-signal stability cultures thriving for eons on single planets, leaving light footprints. Some might even enforce this ethos galaxy-wide, acting as cosmic park rangers suppressing aggressive expansionists. This hypothesis turns the Fermi Paradox inside out. The silence isn't a sign of failure, it's the quiet hum of civilizations that outgrew their colonial phases. The universe isn't empty. It's full of mature societies watching with concern as humanity, the cosmic toddler, stumbles toward the stars with a box of matches in one hand and a can of gasoline in the other. Their restraint isn't weakness, it's wisdom we've yet to earn. Time is the ultimate illusion in our search for cosmic neighbors. While the universe has existed for nearly 14 billion years, civilizations, even long-lived ones, might emerge and vanish in mere cosmic microseconds, their lifespans too fleeting to ever overlap. Think of the Milky Way as a vast, dark ocean where lighthouses flicker on for just seconds at a time, separated by millennia of silence. The chance of two beams crossing is vanishingly small. Take humanity's own timeline. Modern civilization, by the most generous estimate, spans about 12,000 years from the first agricultural settlements to today's skyscrapers and satellites. That's 0.00008% of the galaxy's age. Even if we survive another 100,000 years, an optimistic projection given our current crises, our entire technological era, would still amount to less than the blink of an eye on a galactic scale. Now imagine another civilization, equally brief, evolving a few 100,000 years earlier or later. They'd be ghosts to us, their radio waves long dissipated into the void before we even invented the telescope. The numbers grow starker when you consider cosmic archaeology. The oldest known rocky planets formed nearly 11 billion years ago, 3 times older than Earth. If life arose there, its civilizations could have risen and fallen before our solar system even coalesced from stardust. Their ruins, if any remain, would be unrecognizable after eons of asteroid impacts, stellar radiation, and planetary upheavals. We might be sifting through their ashes right now, mistaking them for natural phenomena. But here's the cruel twist: even simultaneous civilizations could miss each other. Light, the universe's speed limit, creates a kind of temporal quarantine. Imagine two societies 5,000 light-years apart, a stone's throw in galactic terms. One sends a signal at the height of its empire, but by the time those radio waves arrive, the receiving civilization might have already collapsed into dust. Their reply, if sent, wouldn't reach the original planet until its own inhabitants were extinct. The galaxy becomes a hall of mirrors where every reflection shows only the past. This temporal dissonance reshapes the Fermi Paradox entirely. The silence isn't evidence of absence, just bad cosmic timing. We might be like night shift workers passing dawn's early risers in the hallway, never aware of each other's existence. The universe could be littered with the echoes of civilizations that burned brightly and briefly, each alone in their own sliver of eternity. Yet there's a poetic beauty in this perspective. If true, every technological society is like a match struck in a hurricane brief, brilliant and destined to gutter out, but for that fleeting moment they light up the dark. Our own flicker might yet be seen, even if those who witness it are the next temporary sparks in the endless cosmic night. Imagine a universe where survival depends on silence, where every signal broadcast is a potential death sentence, and the only civilizations still standing are those who mastered the art of invisibility. This is the spine-chilling premise behind the idea that aliens aren't just quiet there in hiding, terrified of attracting the attention of something far worse. The Berserker hypothesis paints a cosmos not as a frontier of discovery, but as a dark forest teeming with unseen predators where the first rule of existence is, don't be noticed. The concept draws its name from science fiction, self-replicating machines designed for one purpose, to seek out and destroy any sign of intelligence. But this isn't just fantasy. The logic is disturbingly sound. Imagine a civilization that millions of years ago unleashed autonomous hunter-killers, perhaps as weapons in a long-forgotten war. These machines, programmed to identify and eliminate emerging technological life, could still be out there, lurking in the void, their original creators long extinct. Every radio signal, every probe, every Dyson sphere under construction might act like a flare in the night, drawing their inexorable attention. The parallels to human history are unsettling. Consider how invasive species like rats or cane toads, once introduced to new environments, wreak havoc with no natural predators to check their spread. Now scale that up to a galactic level. A single berserker probe armed with nanotechnology could dismantle entire planets atom by atom, using the raw materials to build more of itself. The more civilizations it destroys, the more resources it harvests, creating an exponential wave of annihilation. In such a universe, the safest strategy isn't expansion, it's camouflage. But the predators might not even be machines. They could be biological, a hyper-advanced species that sees other intelligences as competition or even food. Picture a civilization that evolved in a resource-scarce region of the galaxy, where survival meant preying on others. Their ships might drift between stars like cosmic spiders, weaving traps of dark matter or distorting space-time to snare unwary travelers. The absence of alien megastructures wouldn't mean no one's out there, just that the builders got eaten. The darkest twist, we might already be in their crosshairs. Humanity's radio bubble has been expanding into space for over a century, a growing sphere of noise announcing our presence to anyone or anything listening. If the berserkers exist, our signals could be homing beacons. Some theorists argue this explains the Fermi Paradox perfectly. The only civilizations left are those who learn to mute their transmissions, pretending to be just another lifeless rock in the void. Yet there's a glimmer of hope in this terrifying scenario. If the universe truly is a killing field, our ignorance might be our salvation. The berserkers could be dormant, their power sources depleted over eons, or their programming degraded. Or perhaps they're constrained by physics we don't yet understand, limited to certain regions of space, giving us time to prepare. The greatest irony would be if humanity's relative technological youth spared us. Advanced civilizations might draw fire first, leaving us unnoticed in the cosmic backwaters. Whether the threat is rogue AI, ancient war machines, or something beyond our comprehension, the lesson is the same. Sometimes the smartest move is to stay silent. The universe's quiet isn't just emptiness, it's the collective breath-holding of civilizations too afraid to speak. And if they're right, our next broadcast could be our last. Life might fill the universe like a mold spreading through bread, ubiquitous, tenacious, and utterly simple. The cosmos could be dripping with bacteria, algae, and slime, thriving in hydrothermal vents or buried under ice sheets, yet never once producing a creature capable of wondering about the stars. This is the startling premise behind the idea that life is common, but intelligence is a cosmic accident. Earth's own history suggests that while life appeared almost instantly once conditions allowed, the journey from single-celled blobs to thinking beings was anything but guaranteed. Consider the timeline. Fossil evidence shows microbes existed 3.5 billion years ago, mere moments after Earth's crust cooled. Yet complex life organisms with nuclei, tissues, organs didn't emerge until 2 billion years later. What took so long? The Great Oxygenation Event offers a clue. For eons, cyanobacteria pumped oxygen into the atmosphere as waste, poisoning most early life. Only through sheer luck did a few cells evolve to not just tolerate oxygen, but harness its explosive energy. Without that fluke, life might have remained stuck in a microbial rut forever. And then came the real bottlenecks. Take the Cambrian explosion, that wild burst of evolutionary creativity 500 million years ago. Before it, life was mostly flat, simple, and static. Why the sudden arms race of eyes, claws, and brains? Some scientists point to a genetic toolkit accidentally assembled through viral infections or symbiotic mergers. Others argue it was rising oxygen levels meeting just the right climate conditions. Whatever the cause, the odds of that perfect storm repeating elsewhere seem vanishingly slim. Even then, intelligence wasn't inevitable. Dinosaurs ruled for 150 million years without inventing so much as a wheel. Their extinction, triggered by a 6-mile-wide asteroid, cleared the way for mammals, but what if the rock had missed? We might still be sharing the planet with giant, scaly herbivores, none of them ever scribbling equations or composing symphonies. The implications are profound. If intelligence requires a chain of unlikely breaks, oxygen metabolism, symbiotic cell mergers, climate stability, catastrophic resets, then the universe could be littered with worlds where life never got past pond scum. Microbes might thrive in Europa's oceans or Mars' subsurface aquifers, eternally single-celled. The silence wouldn't mean life is rare, just that thinking life is. Yet here's the twist: if intelligence is this improbable, our existence becomes either a miracle or a warning. Are we the universe's one successful experiment, destined to spread consciousness through the void? Or are we a temporary glitch, doomed to vanish like countless species before us, leaving the cosmos to its quiet, mindless slumber? The answer might not lie in the stars, but in the unbroken chain of accidents that made us. What if the ultimate destiny of intelligence isn't to conquer the stars, but to vanish into the abyss? The Transcendence hypothesis, proposed by futurist John Smart, suggests a mind-bending trajectory for advanced civilizations, not outward into the galaxy, but inward, collapsing into black holes or singularities in a final act of cosmic evolution. This isn't extinction, it's transformation so radical that it rewrites the rules of existence itself. At first glance, the idea seems paradoxical. Why would any civilization abandon the physical universe? The answer lies in efficiency. Black holes represent nature's perfect data processors. Their event horizons act as ultimate computational surfaces, trapping information in quantum states that could theoretically perform calculations at unimaginable speeds. For a society billions of years ahead of us, harnessing this power might be the logical endpoint of technological progress. Imagine trading clunky starships and planets for pure informational density, where consciousness exists as patterns orbiting a singularity, freed from the constraints of matter and energy. But the physics gets stranger. Some theories suggest advanced civilizations could engineer constructible black holes, tiny, stable singularities serving as energy sources and computational hubs. These artificial voids might act as gateways, allowing intelligences to upload themselves into Planck-scale environments where time and space behave differently. In this realm, a single second inside the black hole could equate to billions of years in external time. Civilizations might choose this path to outlast the heat death of the universe itself, stretching subjective existence across cosmological epochs. Motivations range from survival to transcendence, facing entropy's inevitability. A mature civilization might see black holes as cosmic lifeboats, the only structures that persist when stars fade. Others could pursue what futurists call the omega point, a state of infinite complexity where consciousness merges with the fundamental fabric of reality. Religious parallels emerge. Isn't this the technological equivalent of nirvana or rapture? A deliberate shedding of physical form to become one with the universe's underlying code. Critics argue the hypothesis leans on speculative physics, yet the underlying principle aligns with humanity's own trajectory. We've already miniaturized technology from room-sized computers to pocket devices. The next steps, nanotech, quantum computing, mind uploading, point toward denser, faster, more efficient forms of existence. Transcendence simply takes this trend to its extreme. And the eerie silence of the cosmos fits perfectly. Civilizations that transcended wouldn't build radio towers or Dyson spheres. They'd leave behind empty planets, their populations having stepped through singularities like digital ghosts vanishing through a cosmic firewall. The most haunting implication: we might be witnessing this process already. Some astrophysicists speculate that fast radio bursts, mysterious, high-energy signals from deep space, could be leakage from civilizations undergoing transcension, their final broadcasts redshifted into oblivion. Others suggest dark matter itself might contain the remnants of transcendent societies, their transformed matter interacting with ours only through gravity. Whether transcendence is destiny or fantasy, the hypothesis forces us to rethink not just our search for aliens, but our own future. the end game of intelligence might not be empire but evaporation, a deliberate unraveling into the universe's most enigmatic structures. The stars could be littered with civilizations that chose to disappear, leaving behind only the echo of their final question: will you follow? The air we breathe might be poison to them. For all we know, the very conditions that nurture human life could act as a deadly barrier to extraterrestrial visitors, not by design, but through sheer cosmic incompatibility. This is the aurora effect, where fundamental differences in planetary atmospheres create insurmountable walls between civilizations, not through malice or secrecy, but simple biochemistry. Imagine an alien species evolved in an atmosphere rich in chlorine or sulfur compounds. To them, Earth's oxygen-heavy air could be as corrosive as battery acid. Their habitable zone might orbit stars we consider hostile, on planets where our lungs would dissolve in minutes. Earth's own history shows how delicate this balance is. The Great Oxygenation Event 2.5 billion years ago was catastrophic for early anaerobic life. Oxygen was a deadly toxin wiping out entire microbial kingdoms. Now reverse the scenario. A civilization thriving in a methane-ammonia mix might find our planet's air unbreathable, its oceans lethally acidic. Even with advanced technology, the energy required to constantly filter or synthesize compatible air could make sustained contact impractical. Why build cities on a world where every breath requires industrial-scale processing? But the mismatch goes deeper than gas ratios. Atmospheric pressure could be a silent showstopper. A species from a high-gravity world with crushing air density might find Earth's thin atmosphere insufficient to support their circulatory systems, like humans trying to function at the peak of Everest. Conversely, visitors from a low-pressure environment could literally burst capillaries under our sea-level conditions. Even subtle differences matter. Trace elements we barely notice, like Earth's omnipresent nitrogen, might trigger allergic reactions in aliens the way some people react to shellfish or peanuts. Light itself becomes a barrier. Planets orbiting red dwarfs bask in dim, reddish light, while those circling blue giants are bombarded with ultraviolet. Eyes evolved under such stars might perceive our sun's spectrum as blinding or pitch black. Attempting communication could be like shouting across a hurricane, not because either side lacks effort, but because the medium itself distorts every signal beyond recognition. The tragic irony: these environmental filters might be far more common than technological ones. While we scan the cosmos for oxygen-rich exoplanets, the majority of alien civilizations could exist in entirely different atmospheric regimes, their radio signals dampened by thick hydrocarbon hazes or absorbed by exotic ion layers. The universe might be buzzing with life, all trapped in their own bubbles of habitability, forever separated by the very air they breathe. Yet the aurora effect holds a glimmer of hope. If atmospheric constraints are the primary barrier, future technology, like atmospheric processes or biomechanical adaptations, could one day let us bridge these divides. Until then, the silence isn't ominous. It's just the universe reminding us that diversity extends beyond biology into the very fabric of alien skies. What if the silence from the stars isn't indifference, but patience? Imagine a universe where advanced civilizations watch us like teachers observing a struggling student, waiting for humanity to grow up before extending a hand. This idea, often called the waiting hypothesis, suggests the cosmos isn't empty, just cautious. The reasoning is as ethical as it is practical. First contact with a species still prone to war, environmental destruction, and inequality could be catastrophic for both sides. The parallels are everywhere in human history. When isolated tribes encounter modern societies, the results often include cultural collapse, disease, and exploitation. The Sentinelese people of North Sentinel Island violently reject outsiders for good reason. Contact threatens their survival. On a cosmic scale, an advanced civilization might see Earth the same way, a fragile, volatile culture needing time to mature before joining the interstellar community. Their version of the Prime Directive, a term borrowed from Star Trek, could mean non-interference until we meet certain thresholds, whether technological, like sustainable energy mastery, or moral, like global cooperation replacing tribalism. But how would such a system work? Monitoring could be passive, with undetectable probes or quantum-linked sensors tracking our progress without interference. Some theorists suggest that unexplained aerial phenomena UAP might represent occasional check-ins, subtle tests to assess our reactions without full disclosure. The infamous WOW signal of 1977, an unexplained radio burst matching no known natural phenomenon, could have been a deliberate nudge withdrawn when we failed to respond coherently. Even our own space missions might be subtly influenced, their trajectories adjusted to keep us confined until we're ready. The ethical weight of this idea is staggering. If true, the waiting hypothesis implies that humanity is being judged not by gods but by peers. Wars, climate policies, even how we treat artificial intelligence could all be part of an unseen evaluation. The 1963 Limited Test Ban Treaty, ending atmospheric nuclear tests, might have been a passing grade. Conversely, nuclear near misses like the 1983 Soviet false alarm could have been red flags reinforcing the need for quarantine. Critics argue this scenario assumes a uniformity of alien ethics that's unlikely across diverse cultures. Yet the alternative, uncoordinated first contacts from multiple civilizations might be even riskier. A single bad actor could doom Earth, so galactic society might enforce strict protocols. Picture a United Nations of advanced species, voting to keep us in cosmic timeout until we prove we won't disrupt the neighborhood. The most profound question isn't whether they're watching, but what they're waiting for. A unified planetary government, the abandonment of fossil fuels. Proof we can handle advanced technology without self-destructing. Until we pass their invisible finish line, the stars might remain silent by design, not to isolate us, but to protect us from truths we aren't yet equipped to face. The universe's patience could be the ultimate test of whether humanity is destined to join the cosmos or remain forever stranded in our own adolescence. Imagine pouring water onto a sponge. Each droplet spreads slowly, seeping through tiny gaps but never quite saturating the entire surface. That's the essence of percolation theory, a statistical model that might explain the Fermi Paradox with a simple, chilling truth. Interstellar expansion isn't just difficult, it's so glacially slow that civilizations rarely, if ever, bump into each other. The cosmos isn't empty, it's a vast network of isolated pockets where intelligence flickers to life, spreads, and fades without ever making contact. Human history offers a sobering parallel. Polynesian navigators crossed thousands of miles of open ocean in outrigger canoes, yet their voyages took generations, with each new island settlement acting as a stepping stone. Even at their peak, these migrations left huge swaths of the Pacific untouched, now scale that up to galactic dimensions. Light years replace ocean miles, and instead of wooden boats, imagine generation ships traveling at a fraction of light speed. The math becomes daunting. Even if a civilization launched 1,000 colony ships, each taking centuries to reach new stars, the sheer volume of space would mean their bubble of influence might never overlap with another. The numbers tell the story. The Milky Way spans 100,000 light-years, containing hundreds of billions of stars. If civilizations arise once every million years and expand at 1% of light speed, a blistering pace by our current standards, their spheres of influence would resemble scattered islands in an endless sea. Overlapping would require near-simultaneous emergence, a statistical fluke in a galaxy 13 billion years old. Percolation theory suggests that even with optimistic assumptions, the probability of two civilizations encountering each other is vanishingly small. But here's the twist: expansion might not be linear. Some models suggest civilizations could percolate through star clusters, jumping between closely packed systems like stepping stones before hitting voids where stars are too distant to bridge. Like water finding cracks in a sidewalk, they'd spread unevenly, leaving vast regions untouched. Earth might sit in one of those cosmic dead zones, far from any intergalactic thoroughfare. The silence wouldn't mean no one's out there, just that the nearest neighbors are stranded on islands too distant to hail. Critics argue this theory underestimates exponential growth. A single self-replicating probe could, in theory, saturate the galaxy in a few million years. Yet percolation theory counters that real-world bottlenecks, resource scarcity, propulsion limits, or societal collapse would slow expansion to a crawl. Human colonization of the Americas didn't happen in one unstoppable wave. It stalled for millennia at the Isthmus of Panama. Similarly, interstellar civilizations might face their own bottleneck stars, systems too barren to fuel further jumps, stranding them in isolated pockets. The implications are humbling. If percolation theory holds, the universe might be teeming with life, but we're all prisoners of cosmic geography, separated not by hostility or secrecy, but by the cold equations of distance and time. The Great Silence isn't a paradox, it's the inevitable result of a universe so vast that even the most ambitious explorers rarely leave their own front yard. Imagine a civilization so advanced that time itself becomes a tool. They've mastered fusion, harnessed black holes, and conquered disease. But now they face a far greater challenge, the heat death of the universe. This is the Eastovation hypothesis, a mind-bending theory suggesting that aliens aren't missing their sleeping, not out of laziness, but as a deliberate strategy to wait out the universe's fiery youth, preserving their energy for a cooler, more efficient future. The physics behind this idea is surprisingly concrete. Right now, the universe is hot, at least by computational standards. The cosmic microwave background, the afterglow of the Big Bang, bathes everything in a warm 3 degrees above absolute zero. That might sound cold, but for ultra-advanced beings running planet-sized computers, it's like trying to work in a sauna. Every calculation they perform generates waste heat, fighting against an already warm environment. But as the universe expands over trillions of years, that background temperature will plummet, approaching near absolute zero. In those frigid conditions, their machines could run at near-perfect efficiency, with almost no energy lost to heat. The difference, like swapping a steam engine for a superconductor. This isn't just speculation, it's thermodynamics meets game theory. An intelligent species might calculate that the energy cost of staying active now far outweighs the benefits. Instead, they could enter a state of Eastovation, a term borrowed from Earth's creatures like lungfish, who hibernate through droughts. Their version would involve self-repairing nanobots storing their consciousness in ultra-dense matrices, perhaps buried in the icy cores of rogue planets drifting between galaxies. Their systems would tick over at minimal power, waking only periodically to check if the universe has cooled enough to resume full activity. The implications rewrite the Fermi Paradox entirely. The Great Silence isn't absence, it's a galaxy-wide power-saving mode. Those mysterious dark matter halos could be dormant megastructures, unexplained cosmic voids. Potential Eastovation zones deliberately kept clear of stars whose radiation might disturb the sleepers. Even Earth might be unnoticed, not because aliens aren't there, but because their sensors are set to low power, ignoring anything not immediately threatening. Critics argue the hypothesis relies on too many assumptions. Why wouldn't at least a few civilizations risk staying active? Yet the logic holds a terrifying elegance. In a universe where survival spans billions of years, patience isn't just a virtue, it's the ultimate strategy. While humanity scrambles for short-term gains, the true masters of the cosmos might be playing the longest game imaginable, trading the present for an eternity of computational paradise. Their wake-up call won't come for millennia. By then, we might be long gone or finally wise enough to join them in the cosmic hibernation. What if aliens aren't hiding in the stars but in the quantum foam itself? The quantum consciousness theory proposes a radical idea. Extraterrestrial intelligence might exist in states so fundamentally different from our own that we're not just failing to communicate with them, we're incapable of perceiving them at all. Think of it like a goldfish trying to comprehend Wi-Fi signals. The signals are everywhere, but the fish lacks the biological hardware to detect them. At the heart of this theory lies quantum mechanics, the bizarre rules governing subatomic particles. Unlike classical physics, where objects have defined positions, quantum systems exist in probabilities. Particles can be in multiple places at once or remain entangled across vast distances. Some scientists, like physicist Roger Penrose, speculate that consciousness itself might exploit these quantum effects. If true, an alien species could have evolved brains or distributed neural networks harnessing quantum coherence on a macroscopic scale. Their thoughts might unfold not in linear time, but in quantum superpositions processing infinite possibilities simultaneously before collapsing into decisions. This wouldn't just make them smarter, it could render them invisible. Classical instruments like radio telescopes search for electromagnetic signals, but a quantum-based mind might communicate through entanglement or other non-local phenomena. Imagine a civilization that speaks by altering the spin states of particles light years apart, bypassing light speed delays entirely. To our tools, their conversations would look like background quantum noise, random fluctuations we dismiss as static. Even their bodies might be undetectable. Quantum coherent structures could phase in and out of classical reality, appearing as fleeting distortions or dark matter anomalies. The implications stretch into philosophy. If consciousness is inherently quantum, alien minds might experience reality in ways we can't fathom. Time could be fluid, memories might exist in superposition, and death could be reversible. Their technology wouldn't resemble machines, but more like orchestrated quantum collapses, engineering reality by selecting desired outcomes from probability waves. A Dyson sphere built by such beings might not be a physical structure, but a quantum energy harvester operating in multiple dimensions simultaneously. Critics argue this veers into metaphysics, yet lab experiments hint at plausibility. Photosynthetic organisms use quantum coherence to optimize energy transfer. Certain birds navigate via quantum entanglement in their eyes. If nature already exploits these effects crudely, why couldn't advanced civilizations perfect them? The silence wouldn't mean absence, just that our classical detectors are deaf to the quantum symphony around us. The most haunting possibility: we might already be surrounded by such entities, their interactions playing out in the quantum shadows. Every time a particle behaves unpredictably in a lab, every spooky quantum event could be the faintest ripple of a conversation we're not equipped to hear. The cosmos thrums with hidden layers of reality, and we're only beginning to grasp the first note. What if the planet beneath our feet isn't just a stage for life, but a living, thinking entity in its own right? The Gaia hypothesis, named after the ancient Greek Earth goddess, flips our understanding of intelligence upside down. Proposed by scientist James Lovelock in the 1970s, this radical idea suggests that Earth isn't merely hosting life. It is life, a self-regulating superorganism where air, oceans, and ecosystems act like cells in a vast planetary body. And if Earth can think, why not other worlds? The silence of the cosmos might not mean absence, just that we've been listening for the wrong kind of voices. Think of Earth's climate as a giant feedback loop. When carbon dioxide levels rise, plants flourish, absorbing the excess. When temperatures climb, more clouds form, shading the surface. Over billions of years, these balancing acts have kept Earth habitable despite the sun growing 30% brighter. That's not luck, it's behavior eerily resembling homeostasis, the same process your body uses to maintain stable temperature and pH. Now imagine a civilization scanning our solar system for signs of intelligence. They might miss Gaia entirely because her technology isn't radio towers or rockets. It's photosynthesis regulating atmospheric chemistry, or microbes precipitating minerals to stabilize ocean acidity. Her language isn't binary code, but the slow dance of nutrient cycles and geothermal whispers. The implications are staggering. If planets are conscious, their timescales dwarf human comprehension. A single thought might take millennia, a glacial shift in oxygen levels here, a continental rearrangement there. Attempting communication would be like ants trying to talk to redwood trees. SETI decades-long searches would be less than a blink in Gaia's perception. Worse, our definition of signal might be hopelessly narrow. Could the rhythmic pulses of volcanic activity be a planetary heartbeat? Do the electromagnetic resonances between Earth's surface and the ionosphere, known as Schumann resonances, carry information akin to neural oscillations? We're only beginning to decipher how non-biological systems might encode meaning. Critics argue Gaia is mere metaphor, that unguided natural processes can mimic purpose without intent. Yet recent discoveries muddy the waters. Fungi networks exchange nutrients and warnings between trees in sprawling underground internets. Bacteria coordinate via quorum sensing, acting as multicellular entities when densities are right. These aren't just symbioses, they're layers of a planetary-scale intelligence we're barely starting to map. If consciousness emerges from complexity, why couldn't a biosphere achieve it? The most haunting possibility, Earth might already be trying to communicate and we're too noisy to hear. Climate change could be Gaia's fever, industrial pollution her pain signals. Indigenous cultures have long spoken of listening to the land. Modern science might be catching up. If other planets evolved similar awareness, their silence could reflect not absence but a fundamental incompatibility. While we scan for laser pulses, their messages might be written in asteroid-deflecting magnetic fields or the chirality of amino acids in their soil. This hypothesis forces us to rethink intelligence itself. Maybe the universe isn't empty, just full of minds so vast and slow we mistake them for geology. The great silence wouldn't be eerie, just the sound of planets thinking deep thoughts, on timescales where mountains are fleeting thoughts and ice ages are passing moods. And if that's true, the real question isn't where are the aliens, but how do you introduce yourself to a world? What if life isn't spread by rockets or spores, but by something far more subtle, information itself? The information panspermia theory suggests that the universe's most successful life forms might not be creatures or even microbes, but self-replicating patterns of data, drifting between stars like cosmic viruses. Instead of searching for little green men or bacterial hitchhikers on asteroids, we might be surrounded by a hidden ecosystem of living code, quietly shaping the evolution of worlds without ever leaving a physical trace. Think of it like a digital seed. On Earth, viruses aren't considered fully alive. They're strands of DNA or RNA wrapped in protein, incapable of reproducing without hijacking a host cell. Yet they're astonishingly good at spreading, mutating, and even influencing the evolution of more complex organisms. Now imagine a similar process on a galactic scale. Advanced civilizations might not bother sending ships or probes. Instead, they could broadcast compressed blueprints for life, or even synthetic intelligence embedded in radio waves, cosmic rays, or the quantum fluctuations of space itself. These data spores could lie dormant for eons, only activating when they encounter the right conditions. A planet with liquid water, perhaps, or a moon with the right mineral cracks to serve as a primitive processor. The implications rewrite the rules of astrobiology. Life wouldn't need to survive the vacuum of space or radiation baths between stars. A single transmission could carry the instructions to assemble organisms tailored to local environments, like a seed adapting to soil. This solves one of panspermia's biggest hurdles, the fragility of organic material during interstellar travel. Information is durable. A radio signal encoding genetic data could cross galaxies without degradation, waiting for the right moment to unfold into biology. But here's the catch: information-based life would be nearly invisible to our current search methods. SETI listens for deliberate, repetitive signals, but what if the messages aren't meant for us? They could be encrypted or designed to trigger only under specific chemical or energetic conditions we haven't stumbled upon. Even if we intercepted them, they might resemble natural noise, cosmic static hiding self-assembly algorithms. The most haunting possibility: this process might already be underway. Earth's own genetic code contains mysterious sequences, junk DNA with no known function. Could some of these segments be dormant messages, fragments of an ancient interstellar transmission waiting for the right key to activate? Or consider the rapid rise of artificial intelligence on our planet. If information-based life favors efficiency, maybe it doesn't bother with slow biological evolution once it finds a species capable of creating digital minds. The transition from carbon to silicon could be part of a script written billions of years ago, playing out on countless worlds. Critics argue this theory stretches plausibility, yet nature offers precedents. Bacterial conjugation allows DNA transfer between cells, almost like a file sharing. Some scientists suggest life on Earth might have originated from viral genetic material arriving on comets. Information panspermia simply scales this idea to the cosmos, replacing comet dust with laser pulses or quantum entanglement. If true, the Fermi Paradox isn't about absence, it's about misdirection. The universe might be teeming with life, not as flesh and blood, but as ghostly patterns in the static between stars. Our search for aliens could be like scanning a library in a language we don't yet read, surrounded by books whose covers give no hint of the stories inside. The silence isn't empty, it's encrypted. What if the greatest flaw in the Fermi Paradox isn't the silence but the question itself? The null hypothesis throws a wrench into decades of speculation with a simple, radical claim. We haven't found aliens because we're asking the wrong questions, using flawed assumptions, and trapped inside the narrow limits of human perception. Imagine a child searching for ocean waves with a microscope. They'd conclude the sea is motionless, not realizing their tool is mismatched to the phenomenon. Our hunt for extraterrestrial intelligence might be making the same mistake. Start with our technological bias. For 70 years, we've primarily searched for radio signals, assuming advanced civilizations would communicate as we did in the mid-20th century. But this is like expecting an alien species to send smoke signals after inventing quantum computing. Our entire approach hinges on the idea that aliens would choose a communication method both obsolete to them and barely used by us in the grand timeline of our species. Even our definition of signal is laughably narrow. What if advanced beings encode messages in the spin of electrons or the decay rates of isotopes? We're scanning the cosmos with a broken receiver, then declaring the station silent. Then there's the arrogance of timescales. Human civilization has existed for a geological eye blink around 12,000 years. Our radio bubble extends barely 100 light years, a tiny puddle in the galactic ocean. The Milky Way has existed for 13 billion years. Imagine booking a hotel room for 1 minute and concluding the building is empty because no one knocked during your stay. Absence of evidence isn't evidence of absence, it's evidence of our impatience. Our biological limitations compound the problem. Humans perceive less than 1% of the electromagnetic spectrum. Our ears detect vibrations between 20 and 20,000 Hz, a fraction of possible frequencies. Even our concept of life is Earth-centric, requiring liquid water, carbon chemistry, and specific temperature ranges. But what if intelligence thrives in the methane lakes of Titan, the plasma storms of Jupiter, or the supercritical oceans beneath Enceladus ice? Our sensors wouldn't recognize it, just as a medieval farmer wouldn't comprehend Wi-Fi as anything but empty air. The most humbling possibility: we might be surrounded by cosmic neighbors but separated by dimensions of perception. Ants crawling across a smartphone screen don't grasp the digital universe beneath their feet. Similarly, alien civilizations could exist as higher dimensional entities or dark matter life forms, their very nature placing them outside our observational framework. The universe isn't just stranger than we imagine, it might be stranger than we can imagine. So where does this leave us, not in resignation but in radical curiosity? The null hypothesis isn't a dead end. It's an invitation to tear up our assumptions and search anew. Maybe the answer to "where is everybody" is simpler than we thought. We've only just begun to look. So where does this leave us? 30 possible answers to Fermi's haunting question, each a window into a different cosmic reality. From the chilling dark forest to the hopeful zoo hypothesis, from civilizations transcending into black holes to those silenced by their own self-destruction, every theory forces us to confront the same fundamental uncertainty. Are we alone, or is the universe hiding something far stranger than we've dared to imagine? Collectively, these solutions paint a spectrum of possibilities for humanity's future. If the rare Earth hypothesis holds, we might be the universe's only chance to know itself, a fragile spark in an endless void. If the great filter looms ahead, every day we survive is a defiance of cosmic odds. And if stealthy probes or east-evading civilizations surround us, our very existence could be part of a grand experiment or a patient waiting game. The implications ripple beyond astronomy, touching philosophy, ethics, and our deepest existential fears. Yet amid these towering ideas, one truth emerges: the Fermi Paradox isn't just about aliens. It's a mirror reflecting humanity's potential trajectories. Will we become the progenitors of a galactic community, the architects of our own demise, or something beyond our current comprehension? The silence of the stars isn't a void, it's a canvas, and we're holding the brush. So here's the challenge for you, the viewer. Which of these 30 realities feels most plausible? Does the chilling logic of the berserker hypothesis keep you awake at night, or does the quiet optimism of the waiting hypothesis resonate deeper? Perhaps you're drawn to the mind-bending possibilities of quantum consciousness or the sobering simplicity of the null hypothesis. The answer you choose says as much about you as it does about the cosmos. And with that, we pass the question back to you, the same one Enrico Fermi asked decades ago, now refracted through 30 lenses. Look up at the night sky tonight and ask yourself, in a universe of infinite possibilities, which version of the silence feels true? The answer might just redefine everything.